let's take a look at our lesson on piecewise functions. First, let's talk about the definition. So what is a piecewise function? It's a function that is composed of parts or pieces of other functions. Over specific intervals. All right, well, let's take a look at our first one and we'll kind of explore that. So here, let's think about it as a number line. So we've got 3, and when x is smaller than 3, so going this way, the y value is going to be 5. And then when x is bigger than 3, going this way, the y value is going to be 2x minus 1. So what we might do is to, let's kind of focus on the 3. Now notice how there's no equal sign on either one of these. So let's do this one first. When x is smaller than 3, y is 5. Again, f of x is the same thing as y. Y equals 5. So we go up to 5, and when x is smaller than 3, so not at 3, but smaller. Let's see if we can get our ruler here. So we're going this way. Okay, so when x is smaller than 3, y is 5. Okay, great. Now let's look at the other one. Here, when x is larger than 3, y equals, remember this is y equals 2x minus 1. Now you might think, well gosh, I like to graph using the y-intercept, but see, if I start over here at the y-intercept, that doesn't belong to this piece, so that would kind of be weird. So instead what you might do is, let's just plug in a 3. I know it can't be 3, but we've got 2 times 3 minus 1. What is that? 6 minus 1, so 5. Oh, so it actually starts right here. Weird, same place that one ends. That's not necessarily true for everything. It just happens to be. Our slope is 2, so we rise 2 and run 1. Rise 2 and run 1. So we'd be right there, and we'd have our other piece. Okay, great. So there's our very first piecewise function. Okay, let's do another one. This time, and notice that again, there's no equal sign. X is bigger than 4, x is smaller than 4. Doesn't really matter which one we start with. So this case, when x is larger than 4, so let's kind of focus on this. Let's just see, what would that look like? Ooh, actually, let's back up. On number 1, I got so excited about graphing that I forgot to read. State the domain and range of each and identify the intervals over which the function is increasing and decreasing. Okay, so let's do that. So domain and range. So here we go, our domain. It doesn't say whether they want it in what form, whether we use, set notation or interval notation, doesn't really matter, but let's look at our domain. Our domain is basically everything except 3. 3 is not part of this. So we could say, if we use set notation, all x such that x does not equal 3. Okay, that works. Our range is, let's see, our smallest y value is 5. So all y such that y is greater than or equal to 5. There's our domain and range. intervals of increase, decrease. So this is interesting. This interval from negative infinity to 3, there is no increase, decrease. It's constant. It's a constant. So we basically just have increase. Remember the increase we write in x values from 3 to infinity. Decrease, there isn't any. There is no location where it decreases, so that would be none. Okay, great. So now let's move on to the second one. Here we're looking at the space around 4. So 4 is our divider, if you will. On the left side of 4, we're going to be looking at the line, and on the right side of 4, we're going to be looking at the parabola. So one of the easiest ways to do this to me is to, start with the 4. Let's just let's work on x is larger than 4. Let's work on the top piece, and we'll just do like a little t-chart. So when x is 4, which we know it can't be exactly 4, we'll have to put a hole there, but we need to know where it starts. We would do what, negative 1/2 times 4 squared, which that would be 16. What is that, negative 8? Okay, so at 4, we would go down to negative 8, which would be right here. Okay, now this is a parabola, and it's negative, so it's going to go down. You may remember that from Algebra 1, but just in case you don't, why don't we just for fun, let's find out what happens when x is 5. That would be negative 1/2 times 5 squared. So what, negative 25 halves, which is, let's see, it's just going to basically go down like this. And since it's off the graph, I'm not going to put a point, but 25 halves, what is that, like 12.5? So it'd be down here somewhere. Okay. So now let's work on the other piece. When x is smaller than 4, again, I like to do a t-chart just so I can get a feel for what's going on. I want to start at 4. So that would be negative 3 times 4 plus 8. Let's see, what is that? That's negative 12 plus 8, so negative 4. Okay, so 4, we would be at negative 4, and there'd be a circle again because there's no, it's not or equal to, it's just less than. And since it's a line, I kind of like graphing lines. They're easy, right? We're just going to do the slope. So rise 3, run 1, rise 3, run 1. And so let's graph that little guy. Something like this. All right, so that's our graph. Now let's work on our questions. So our domain, let's see, much like the other one, it's everything except 4. So all x such that x can't be 4. The range, a little different. Let's see, so the range, if we're doing set notation, all y such that, let's see, y has to be larger than negative 4, or y has to be smaller than negative 8. Okay, so let's see. As we read from left to right, we look at decreasing. It's decreasing. So we've got a decreasing from, remember it's x values, negative infinity to 4. And there's some weird stuff going on at 4, so we can't just go straight through. And then from 4 to infinity. All right, great. So let's go to our second slide, see what we got going on over here. So on the first question, it says evaluate. So let's think about what that word evaluate means. Evaluate typically means plug in or substitute a value in and come up with a value, right? Evaluate, come up with a value. So they want us to find f of 0 first. Well, it's a piecewise function, so we need to see which piece is x equals 0. Which piece does that fit into? And we can see that the x is greater than or equal to 0, that fits in the bottom piece. So f of 0 would actually be 0 plus 2 or 2. Okay, so that's how we have to make a judgment first of which piece do we need to use, and then we substitute. So f of -4, let's see, that's where x is smaller than 0, so f of -4 would go into that top piece. So that would be negative, whoops. So there's a negative there, and then I plug in the -4. So that gives me -4 times -4 is 16. And so that gives me, what, a -14. And the last piece is 4, f of 4. And that's when x is, so it would go into the bottom piece because that's where x is bigger than or equal to 0, which is where the 4 falls. So that would be 4 plus 2 or 6. Okay, so that's evaluating. The last thing that we want to do is, let's look at a different concept, and that is take an absolute value function and write it as a piecewise. It's a pretty good skill. It's good to know to kind of see how that works. So we can write it in absolute value, or we can write it as a piecewise. It's not both of them, it's one or the other. The first thing that we would need to do is to find the vertex. And if you recall from your work with absolute value in previous math classes, to find the vertex, we set the expression inside the absolute value equal to 0. That's what we do to find the vertex. So x plus 1 is 0. So x equals -1. So my piecewise is going to be built around an x value of -1. Now, for this particular one, x absolute value x plus 1, it would look like a V, right? And so that would be positive here. It's a positive slope on the right side, and it would be a negative slope on the left side. And so we're splitting at -1. So it's going to be a positive x plus 1 when x is greater than or equal to -1. And then it's going to be the opposite of that when x is less than -1. And you don't need to distribute. You can just leave it like that, opposite. Okay, so the second one, let's look at it. So let's find where its vertex is. The vertex, again, is the bottom part of the V. So we've got x minus 4 is 0, so x equals 4. So our vertex is at 4. So f of x is going to be, so let's write our piecewise. So we would have the positive part 3 times x minus 4 when x is greater than or equal to 4. Or we'd have the opposite of that, x minus 4, when x is less than 4. And you may ask yourself, well, does it matter which one of these inequalities I put the equal sign with? Does that really matter? I mean, technically no, but typically with absolute value, I know the definition, let's just kind of, the definition of absolute value of x, just going to throw that in, that's a fun one. That's when x is greater than or equal to 0 and x is less than 0. So the definition of absolute value of x puts the extra equal sign with the greater than one. So I'm just following along that pattern and putting the equal sign with the greater than piece. All right, and that concludes our lesson.